fall under the category of classification. You may use any type of classification learning algorithm to solve this problem. We have different others learning algorithm which may use for classification, and definitely you may use at the block replaced by the learning algorithm. So in the block of the learning algorithm you may use a decision tree, which is actually our task I am going to discuss, and then rule based method, memory based reasoning, neural network, which we have already discussed. You may replace that learning algorithm block which is being defined in the first slide in this lecture by the neural network. You may use of Bayesian networks, support vector machine, k nearest neighbor. These are all conventional algorithm used for classification or used as a classification technique. It means that in the previous slide we talk about some practical application, and in this slide we discuss some classification technique and algorithm which is directly used in any machine learning style fall under the category of supervised learning or classification. Here, this is the second step from the first slide. In the first slide, you have already seen a pictorial view which being defined by the training set, and we have some learning algorithm. The learning algorithm arrow fall in the learn models, and another arrow fall in the is from training set. So by the combination of training set in the first slide, I have already shown in this lecture, and the learning model is combined to produce a model. The actually look like. This is the example of model you can see in the right side of this slide. This is the model is being produced by introducing this data set. Remember, this is the training data which we have already discussed with the three unknown attribute, but here we are defining the attribute categorically. Here we make use of refund as an attribute, marital status as an attributes, and taxable income as an attribute. So these are the three attributes which is not being shown in the first slide as a training set, but here we are I'm categorically define the training data set which is comprises of these three attributes: refund, marital status, and taxable income. Got it? And this is my class. I actually make use of the combination of these three parameters and attribute. You have to classify, or you have to classify the particular result which is being defined. Depends upon the condition, right? That's why we call it the supervised learning, because at every attribute or combination of attribute having some result, and you have to identify the result based on their model. Actually, what is practically happening, you are introducing this data set or a training data set with the learning algorithm which we have already discussed, which we are making use of decision tree, and we will discuss how the decision tree will do it. Whenever you're going to apply the decision tree as an algorithm, and this is my training data, then your result in term of model will become this. So you can see that in this diagram here we have a model, you can see, and this is decision tree model which is being drive with the help of this training set which is defined here, as well as the decision tree algorithm which is being introduced in the learn model block. After passing through the learn model block, you will find a model which is being defined in term. Here the model is there, and you can see in this model which is being shown in this diagram and drive with the help of the decision tree as a learning algorithm, you can see all attributes are present with their class. Here you can see that whenever we start with the splitting attributes, we start with refund. Refund had two condition, no or yes. Got it? We have a marital status. Marital status has three conditions: single, divorce, and married. Whereas the taxable income is minimum range is less than or greater than 80, whereas the maximum range is greater than 80. So it means that this is basically all type of attribute which is being defined in a training set is clearly defined or identify or used to make this decision tree model, and based on these attribute it will help you to test this particular model with a different set attribute which is not being used in the training data. It means that now, till now you people are aware what I'm going to say. This is my training data set. Again, I'm repeating my talk. This is my training set, got it? And this is the model which is being generated. The question here is, sir, how this model is generated from this training data set? This question will be answered in the upcoming slide, because in the upcoming slide we will talk about the decision tree, how the decision tree will work to produce this model. Got it? With the help of this training data set. So this is basically the task of this lecture and the another lecture on decision tree. Then you will be able to understand what are the basic philosophy and a mathematical model used to retrieve this type of model, making use of the training data set which is being provided to the system. Now, you people are aware of it. Now I'm in a position to define, this is my training set. Got it? This is my training data and this is the model. So as now go back to the previous diagram, here we have a training set which we make use of to develop a model, and we have already developed the model. Actually, this white block of model is being defined in this way. So here this is the description of the model you can see, and now you are in a position to identify this is your model which is being generated by this data set. How it is generated, this is another question I will discuss in detail, but at this stage you should be able or capable to understand what I'm saying and how the model can be a drive from the decision tree algorithm. This is another part of the lecture, but here I'm just directly talking about whenever a training data set with the help of the decision tree algorithm, it will provide you a model which is called decision tree based model. Whenever your model has been established making use of this training data set and decision tree algorithm, great, and then you have to apply, you make use of this test set on your model to verify or validate your model, either your model is capable to work with some unseen data or not. Why we call it as unseen? You can see here any combination of these three attributes is not repeat in the test set. It means your test set is so called unseen and which is not being used during training whenever the model is being built, right? Here, this is your model. I have already discussed because you have already seen this is the model which is started from the refund, and this is my develop model which is being developed with the help of the training set. Got it? And the decision tree learning model. Now what we have to do, we have to introduce some test data. Here you can see that we have a test data, refund no, marital status is married, and taxable income is 80K. Got it? This is actually the data, and what I'm going to do, I'm going to apply this data to classify the result either on the basis of these three information. If we can able to classify this result, either it is cheat or not. Let's see. Here start from the refund no. Whenever we say refund no, then we'll talk about marital status. Whenever we talk about the marital status, if the marital status is married, it means there will be no cheat. So you don't need to go for further attribute, because you already know whenever this flow is being defined, then the result will become no. It means you have a capability to identify the test data on applying on this particular model which is being derived from your training set, and the decision tree will give you the result no over here. This is basically the idea behind the entire algorithm working. So you directly show this thing, because whenever you are making use of any tool like MATLAB and any other tool which you are using to apply a decision tree, they directly give you the result. You apply the data set to the module, right? And the data set, whenever the data set is being introduced in your software or a tool, then you directly select the decision tree algorithm, and then after clicking you directly get the result in the form of the decision tree which I am already defined over here, right? And whenever you apply any test set, then definitely the result will be defined one by one. So but what is the actual philosophy behind this is basically the philosophy is the same, because this thing or this model is being developed with the help of the training set, and then you are testing your system with unseen data. So here you can easily be identify at this stage, every student which who are listening to me can easily be identify the result. If I want to find either the person will cheat or not, so you can directly say no, because you are not seeing yourself, you are saying on the basis of the model and you are going to apply the test data on the drive model from your training set, and on the basis of that training set you are talking about the person having this particular attribute will not cheat in future. This is basically an idea how the model can apply on the test data. At this stage, you people are very much aware how the decision tree work. What are the basic principle behind a decision tree? Now let's move towards the concept and your question you were asking about, sir, how the training set with the help of the decision tree has been transformed into this model. What are the parameter and why you are selecting the parameter in this way? Then the model has been developed. So definitely we will discuss what are the baseline mathematics and the philosophy behind to develop this model, because in a software or tool this methodology and philosophy is directly implemented. So whenever you're going to use the tool or any tool which is using MATLAB, then directly give you the result, but you never know what is actually going on behind this mathematical model, because whenever you will be able to understand the statistics and the learning nature or the mathematics behind this a particular model which is not being defined, because you are directly use the tool and normally we make use of the tool directly. This is the base science